Hello and welcome to this presentation on wastewater LCI version 5 on what is new in the tool. My name is Ivan Muñoz and I work for 20 LCI Consultants in Barcelona, Spain. And I am the developer of wastewater LCI. Now, first thing I wanted to mention is that if you are new, completely new to wastewater LCI, then I would strongly encourage you to first go in our YouTube channel and watch the recording of the webinar we held in 2021 on wastewater LCI version 4, because I think that webinar gave a very thorough, comprehensive overview of the model that you might benefit from. In this presentation today, we're only going to talk about what is new in the new version, but we will not touch upon the model fundamentals as such. And also, before I continue, I would like to mention that version 5 has been made possible thanks to the collaboration between 20 LCA Consultants and Procter & Gamble. Procter & Gamble, in fact, has also been one of the founding members of this project. So they helped us develop the tool as early as 2015, 2016, when we started with this development. So thanks to P&G for their continued support. So this is a list of topics I will touch upon today. Links to ecoinvent version 3.8, the modeling of solid debris in wastewater, changes to the landfilling model, the discontinuation of the nitrogen fertilizer model, grouping of activities in SimaPro, the expansion of database, and some changes to the layout in the scenario sheet. So let's jump into the first topic, which is the ecoinvent version. As you know, in version 4, we were linking to ecoinvent version 3.6 in its consequential system model. Now, in version 5, we are linking to version 3.8, but also we are giving the user the option of automatically shifting to any of the other system models. So it is possible to use the consequential, the allocation at point of substitution, or the cutoff versions of the ecoinvent database. That's all about ecoinvent, and now let's jump to the next topic, which is the modeling of debris in wastewater. And here by solid debris, we refer to macro scale materials that can be present in wastewater, such as rags, wood fragments, pieces of plastic, wipes, etc. This is a picture of what we mean, these kinds of materials that make their way into the inlet of wastewater treatment plants. Now, these materials are typically removed by wastewater treatment plants in the pretreatment stage, and they are handled separately from sludge. So in this flow diagram here on the left, you can see, on the right, you can see the pretreatment stage, and you can see how we have these flows coming out, this trash and scum. These are the flows we're trying to model here. Now, the modeling of such materials in wastewater LCI is only possible now when you are doing a tier 2 assessment. In a tier 1 assessment, we are omitting these materials because they are, in principle, they are produced in relatively low amounts compared to sludge, for example. But if you want to model such materials, it can be done as a as a tier 2 assessment. And for this, what we have done is to introduce a new fate factor in wastewater treatment plants. It's called F-PRET. And this factor reflects the percentage of the material that is going to be retained by the pretreatment stage of the wastewater treatment plant. And what we suggest is that this factor takes a value of 100% in wastewater treatment plants, which means that the material is entirely removed. Of course, the user is free to use a different value. The only exception to this is in septic tanks, where this fate factor is forced to 100%, meaning that the material is always going to be retained by the tank. It's never going to be, go into the treated effluent. So it is retained in the tank and then removed from the tank when the tank is dislodged. Of course, if the material is labeled by the user as degradable, then emissions from degradation will be accounted for in different parts of the model, such as in sewers, in septic tanks, in direct discharges, landfill, etc. In terms of the inventory, these materials will only receive the environmental burdens associated to the pretreatment stage of the wastewater treatment plant. So that means some overhead energy consumption related to functioning of the plant and the specific fraction of energy that is used in the pretreatment stage as such, but not in other parts of the plant. And regarding disposal, we only consider two options: landfilling and incineration. Then what we do is to calculate a country-specific disposal mix. And this is automatically calculated from the corresponding disposal mix for sludge. And here you have an example of this. What you see here is that sludge disposal in this particular case is sent to composting, land farming, controlled landfilling, and incineration with rates of 25% each. Underneath that, you have the calculated pretreatment waste disposal. Now, what we do to calculate this pretreatment waste disposal is first, the sludge composting and land farming options are omitted because pretreatment waste is not going to be sent to composting or land farming. And then we take the remaining options that are landfilling and incineration, and we simply scale them up to 100%. So in this example, we get 50% controlled landfilling and 50% incineration. Then we have changes to the landfill model. This is another topic in version 5. In version 4, the landfilling calculations are fixed for two types of landfill: a controlled landfill and an uncontrolled landfill. Of course, the inventory is going to be dependent on the composition of the waste that is going to be landfilled, but that's about it. In version 5, we are making the model more parameterized in terms of the extent of waste degradation, and we adjust that degradation also for climate conditions. And we also parameterize landfill gas management. Let's talk about the first thing, extent of waste degradation first, climate conditions. What we said in version 5 is that the maximum degradation of organic matter in a period of 100 years in the landfill is 70%, considering that the landfill has the right conditions of moisture and temperature. This 70% value is the suggested value by the IPCC's guidelines on greenhouse gas inventories, and is the value they suggest for highly decomposable waste. So this maximum value is then adjusted for the local climate conditions in terms of moisture and temperature. So if we don't have sufficient moisture or temperature, we would expect a lower degradation in this period of 100 years. The adjustment is made with the alpha parameter proposed by Gabor Doka in his latest models for landfilling developed for ecoinvent. So this alpha parameter takes a value of between 0 and 1 and is calculated as the product of two parameters called alpha P and alpha T. Alpha P is related to precipitation, alpha T is related to temperature. So in the end, the actual level of degradation we expect is the product of the maximum times the alpha parameter. What we have seen after implementing this in the tool is that the effect of alpha is really only seen in countries with very extreme climate, so very dry countries or very cold countries. Otherwise, it's almost negligible. Then we have the parameterization of landfill gas management. In version 4, this management was fixed according to values in Switzerland, as reported by Gabor Doka in his landfilling model. But now we are parameterizing these aspects. And the default values we take are European ones, but they can be changed by the user. Here you have a screenshot of these parameters. In fact, the list is for the whole list of parameters related to landfilling, so things that the user can change related to landfilling. In terms of landfill gas, you can see that we have a certain percentage of landfill gas collected, percentage for collected gas that is going to be used for energy production or flared or vented. You have the thermal and electric efficiencies of the landfill gas motor. And so all these parameters here can be changed by the user if you want to reflect different conditions. This is always for a controlled landfill. Next topic is the discontinuation of the nitrogen fertilizer that we provided in version 4. And let's give you a bit of background here. In previous ecoinvent versions, that's 3.6 at least and below, the market for mineral nitrogen fertilizer had, in our opinion, too high impact. So in the consequential system model, for example, the footprint was about 16 kilos CO2 per kilo nitrogen supplied. And this was due to the contribution of calcium nitrate to the market mix. We think that this was not correct. And in order for the model to give a more accurate, in our opinion, contribution of nitrogen, so whenever, for example, you send wastewater sludge to agriculture, you will have a nitrogen credit. So instead of linking to the ecoinvent dataset, what we did was to provide our own alternative nitrogen fertilizer model in the tool. Now, in ecoinvent 3.8 that we are using now, it seems like calcium nitrate is no longer part of the nitrogen mix. And so we think it's no longer necessary for us to provide an alternative model. So we can just simply link to the default dataset in ecoinvent. This, of course, simplifies the tool and probably also the experience by the user, because you don't have to import, the inventories for this fertilizer to SimaPro. Next topic is the grouping of activities in SimaPro. Another new feature that hopefully improves in terms of contribution analysis when you are carrying out calculations in our analysis in SimaPro. So if you are a SimaPro user, you will probably be very familiar with this kind of graph. What I did here was to export to SimaPro the inventory for 1 kilogram of average wastewater discharge in Denmark, and I pushed the button to assess that data set for greenhouse gas emissions. And this is how you would look at the results in a graph format. Of course, you can also look at it in a table format in SimaPro. But the thing is that you will get the contributions, in this case, for 85 activities. And it's perhaps not that easy for you to interpret what are the key drivers explaining the emissions here. So you have 85 activities. Some of them might be related to sludge disposal. Some of them might be related to infrastructure or to operation of the wastewater treatment plant, but it's not obvious when looking at the results. So this is why we have come up with this new format, and this is in addition to the previous format. So it's not like we are substituting what we had before, but this is just an addition, an option that we give the user to export the inventories to SimaPro in this new format, where activities in the inventory are classified into a total of 19 items that you see here in this list. Some of them are related to the operation of the wastewater treatment plant or to infrastructure. They can be related to sludge disposal, etc. We look at an example of what it looks like. This is the same wastewater I analyzed before, but using this new grouping of activities. As you can see, the number of activities that we have here now in the graph contributing to the greenhouse gases is much lower. And the idea is that now it should be much easier for you to interpret the results. You now get quickly an idea of whether the emissions are coming from the wastewater treatment plants or from sludge disposal, if the credits are related to fertilizers or to incineration of sludge, etc. And how do we do this? We have created a new sheet in the tool. And so instead of exporting the inventory from the ready-to-CSV sheet, we export from this new sheet called ready-to-CSV grouped. And once you import into SimaPro, you will see that two new subfolders are created under the root folder for wastewater LCI. So these two folders are called grouped and groups. In principle, the inventories you want to assess with SimaPro are located in the grouped subfolder. So the one I just was showing you in the previous slide would be this one, average wastewater decay grouped. What you find in the other subfolder groups is the 19 underlying activities that this one, average wastewater, is using. You can also analyze them if you're interested, if you want to go deeper into the analysis. Then we have, as a next topic, the expansion of the country database. We have now reached a total of 100 countries. It was 92 before. But also we are providing data for two regions, namely the EU plus UK, so that would be the former EU 28, and a global average. These two regions are calculated as an average with the individual countries weighted for population. And then in the map, you can see the new individual countries we have added. And they are mainly from Latin America, Africa, and Asia. Then we have certain changes to the scenario sheet, and that will be the last topic I want to cover. But that's easier if we just look at them directly in the Excel file. So let's jump into the Excel file. Here we have the tool in the scenario sheet. Changes I wanted to discuss are, first of all, the row number 10, where we have the name of the wastewater mixture. So in the previous versions, all wastewater mixes were called average wastewater. Sorry, wastewater mixture, but now it is possible for the user to define a new name for the wastewater you want to analyze. In the next row, we have the definition of the ecoinvent system model. So this is a drop-down menu, and you can select the system model you want to use. Some more changes you will see are in rows 38, 39 related to nutrient removal in wastewater treatment plants. Here you will see that the option of nitrogen removal with methanol has been removed from this sheet. This is still available in the model, so if you want to model nitrogen removal with methanol, you can still do it, but it's not part of the country settings. It's a generic parameter that you can find in the parameter settings now. So if we jump to parameters, you will see that there's a field for wastewater treated in plants that use methanol. And so you can still define here a value. As a default is 0. Also bear in mind that this percentage will only be applied for plants that have tertiary treatment. Okay, more changes we have are related to the degradability and methane correction factors. Those are now automatically calculated, so there's no longer the option of introducing them manually. They are simply calculated based on country database data or on the numbers in this sheet. And I also wanted to mention that whenever the user wants to use user-specific data, so instead of using the database as a source of scenario data, when user-specific data needs to be used, as you know, this is done by entering data in column R. Now, there are a few fields now that you can see marked with the red mark of a comment, where it is no longer necessary for you to enter values. I can give you a very simple example for you to understand. Let's say we want to assess a wastewater discharge in Denmark, and you want to deviate from the average scenario and define a new scenario. It is very likely that you want to change things like how the wastewater is treated, what type of plants, etc. But you probably want to still rely on the database information in terms of climate. So you want to still use the average temperatures in Denmark that are stored in the database. So if you leave these fields blank, the database information will be used. Of course, if you want to override this, you can write data here. So if I type here 10 instead, I will see that the 10 appears here. So the user data always will override the default. But it is no longer necessary to fill these fields. They can be left blank. And last thing I wanted to show you is that you can see here in the fate factors that we have this new field called FPRIT related to the modeling of solid debris. And So we have now 4 fate factors. Okay, so that is all I wanted to explain today. Let's jump into the presentation again. Just again, very quickly, just for you to know that just as in the previous version, both the user manual and the model documentation are freely available in our website. So you can find them as PDF files there in our website. And that's all I wanted to cover today. So thank you very much for your attention. If you have any questions, feel free to contact me at ivan.munoz@lca-net.com. Thank you very much. Bye-bye.